Hi guys, so let's go over the D flip-flop. So every time you have a synchronous memory, so that's gonna be called a flip-flop. Okay, so synchronous memory, flip-flop, and the most basic type that you have is the D flip-flop. Okay, DFF, D flip-flop. So D flip-flop works like a D latch, but instead of an enabler, you do not have an enabler in here, you have a clock. Okay, and if you have, so it looks like a triangle shape over here. Okay, so if you have something like this, so you're going to call it like positive edge triggered flip-flop, positive edge triggered D flip-flop. But if you have like a circle over here with the triangle, in that case it's gonna be called negative edged D flip-flop. Okay, so now let's go ahead and do an example with the timing diagram with the D flip-flop and the latch, so you guys can actually see the difference between them. Okay, so let's go ahead and do that. Okay, so here is the timing diagram. Okay, so we need to complete this timing diagram for the outputs for the Q1 and Q2. And here we have, like I explained over here, we have, if it's a triangle symbol, it's a flip-flop, and if it's an enabler, that means it's a latch. Okay, and if you guys don't know what's a latch and how it works, and the timing diagram, how do we create it, so I already made a video on that. That's the previous video in this playlist, so you can go ahead and check that out. Okay, so let's go ahead and continue with this one. So here the first output that we have, Q1, you see, so the first output that we have is for the flip-flop. Okay, and the flip-flop, it's connected to the clock. Okay, and here this is the D input. So how do we create the diagram for the flip-flop? Okay, so first of all, since it's a flip-flop, remember it's there's no like a dot over here, so that means it's positive edge triggered. Okay, so positive edge triggered, which means we're going to look at the clock, the diagram for the clock, and you're going to look at every time it's going from the low input to high. Okay, so every time you have like low to high, so that's a positive edge, like low to high. So the input is going from low to high, so that's a positive input. Okay, so if you have like here, you see you're going from positive to negative, so no, you're not going to look at this one. So only when you have the going from bottom to top. Okay, so from low input to high input, so that is low to high as well. So you only need to mark the ones that where you're going from low to high. Okay, so low to high here, low to high here. Okay, now for the output, so if you look at here, so here for the positive edge triggered, if you see the Q, okay, so whatever the Q is, it's going to follow that until the end. Okay, and this is going to be given to you like this one, the first, because you don't know before that, right? So it's gonna be given to you, so don't worry about that. And the next ones you're gonna have to worry by yourself. Okay, I mean, you're gonna have to take care of it, yeah, whatever it is. Okay, so here we have a positive edge triggered, right? At the positive edge, we see what? We see the D as high input, right? So we're going to make it as high. Okay, and then it's going to remain high. Whatever happens in the middle, we don't care. Okay, it is going to remain high until the next. Okay, so now we hit this one. Now what do you see? You see a low, right? So you're going to make it low. So this is how you're going to create the diagram, the timing diagram for the flip-flop. So I hope it makes sense. So if it was a negative edge triggered, what we would do, we would look at these lines, right? Because it's going from high to low, so we would look in here at these lines. But since we have a positive edge triggered, we're only looking at the lines, at these lines. Okay, when we are going from low to high. So low to high, what do we have? We're going to, from low to high, we're going to look at the D input. So the D input, we have a high, so we're going to make it high. Okay, and we're going to make it high until the next time we get the low to high. Okay, and then we're going to check again. If it's low, we're going to make it low. Okay, so this is pretty much it. It's really simple. Okay, you're checking for the clock from low to high, and you're going to check because it's going to depend on the D, whatever it is, so that your Q is simply going to depend on the D. And for now, for the Q2, you see this is an enabler, so that means these are latches. This is flip-flop, D flip-flop, and this is latch. So enabler and the D input. The enabler is connected to the clock. So our enabler is the clock now, and the D is the D as well. So here, like I explained in my previous video, for the enabler, every time the enabler is equals to 1, so the output depends on whatever the D input is, right? But if the enabler is equals to, so I'm right over here, if the enabler is equals to 1, okay, if it equals to 1, so the output, it's going to depend on D. But if the enabler is equals to 0, so in that case, what happens? It is going to hold whatever the state it was previously in. Okay, so now since the enabler is connected to the clock, we see so like I said, the initial input would be given it to you. Okay, so don't worry about that. Okay, so let's just say this is given to you. Okay, now you see here this is 0. Okay, so since it is 0, enabler is equals to 0, and yeah, so the enabler is equals to 0, and now since it's 0, that means it's going to hold in whatever state it was previously in, so we don't even look at the D. Okay, so it's going to remain just like this. Okay, now here in this time, so here we see that the clock is equals to 1, right? It is high level, so that is 1. So if it is equals to 1, it's going to depend on whatever the D input is. Okay, so now as long as it's high, it's going to depend on this one. Okay, as long as it's 1, so it's high in all of this region. Okay, you see 1 1 1 1, so it's going to depend, the output is going to depend on whatever this thing is doing. Okay, so you're going to make exactly this thing until this line, right, the dotted line that you see over here. So you're going to simply follow this thing. Okay, I hope it's making sense. So now it's 0. Okay, and then again it's 0, and when it's 0, what do? We're going to hold the state that it was previously in. So it was 0, so it's going to remain 0 0. Okay, it's high again, it's 1 and 1, it's high again, so what do? We're going to, the output is going to depend on whatever the D input is. Okay, so the D input is like this, so we're simply going to follow this thing, and this pretty much completes our timing diagram for these two. And you know, in the final exam, I had a question like this, but here we didn't have latches, we only had for flip-flop. Okay, and for the flip-flop, like this diagram here, like we have, you know, the positive edge triggered. It was a positive edge triggered, I remember, but here we're asked to like to make the output, right, to draw the timing diagram for the output. But in the exam, you know, the clock, it was given to us, and the Q, it was also given to us. But instead, what we had to do, we had to find the Q, the D, and it says to make the diagram for the D, and this was a final exam question. So if you guys want, I can make a video on that as well. So if I get like so many comments of you guys asking me to make a video, so then I'll make it. Otherwise I just leave it. So if you want, you guys can think about the solution of this one. like how would you approach it if you had like a positive edge triggered flip-flop and you had like a clock and you're already given the input and you have to find the D. Okay, so that was the final exam question I had.